Today I'll be giving you a rundown of how to use scientific notation. As you can see, we have a really big number on screen, 45 billion. But it would be really annoying to write that whole thing out, so what would be a better way of representing it? Well, we can use scientific notation for this. I think the best way to explain it is probably with an example, so let me show you. Let's look at 45 billion. How do we express this in scientific notation? Well, you take the first digit, then you put a decimal point, and write the remaining significant figures after the decimal point. Then, we're going to write times 10 to the power of some number. And this is how you figure out the power. Look at the original number, so the long form of 45 billion, and count how many places left or right we had to move the decimal place to write it in the second form. So let's count for this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 to the power of 10. If we'd move the decimal place right, it would be 10 to the power of negative 10. So a positive power signifies a bigger number, and a negative power signifies a smaller number. And here's a practice question before we move on. So try writing 86 million in scientific notation. Okay, so to do this, first we write 8, then put a decimal point, and then write 6. And then we count how many places left or right we moved the decimal place. So in this case, we moved it 1, 2, 3, 4, 5, 6, 7. So 7 places left. So we would write 8.6 times 10 to the power of 7. And that's the final answer. Now what if the number didn't just end in a bunch of zeros? For example, 147,893,462. It wouldn't really make sense to write it as 1.47893,462 times 10 to the power of 8, because that takes more work than just writing the original number. So this is where significant figures come in. In an exam, the question might ask you to use a specific number of significant figures. If not, you might be able to choose a number at your own discretion, or maybe whatever course you're doing has a rule like all answers to 3 significant figures. It really depends, but let's just say we want to write this number in scientific notation to 3 significant figures. That just means we take the first 3 digits, so in this case 147. We also use normal rounding rules, so if the digit after the 7 is 5 or higher, we need to round it up. So in this case, we actually use 148. So now instead of writing 1.47893,462 times 10 to the power of 8 like we did before, we would write 1.48 times 10 to the power of 8. Try this one for practice. Write 267,392 in scientific notation to 2 significant figures. So because it wants 2 significant figures, we look at the first 2 digits, so 2, 6, but because the number after the 6 is 5 or higher, it's 7, we actually use 2, 7, so we would write 2.7 times 10, and then we need to figure out the power. So let's count how many places we move the decimal point. 1, 2, 3, 4, 5. So our final answer is 2.7 times 10 to the power of 5. Now finally, I think we need to do an example with a very small number. So try writing 0.00000015934 in scientific notation to 3 significant figures, remembering that the power is positive for moving the decimal point left and negative for moving the decimal point right. So try that one. So 3 significant figures mean we use 159, and we don't need to round it in this case. So I'm going to write 1.59 times 10, and then we're going to count 1, 2, 3, 4, 5, 6. So we move the decimal place 6 places to the right, so that means the power is -6. So the answer is 1.59 times 10 to the power of -6. And that's essentially everything you need to know for using scientific notation, so thanks for watching.